Chapter 4, Linux File System Management, Part 1. So in the first half of our lecture this week, we're going to go in and deep dive into the Linux file system. Now we've been talking about the file system up to now, and we're going to do a little bit of review on some of this stuff. But this time we're going to get right down in the weeds. We're going to look at some new commands for maneuvering around inside our file system, and then we're going to go in and actually explore how the operating system uses the file system to store data on its disk. So we already talked about this before, the file system hierarchy, right? But only now we're just putting a name to it. Hierarchy, hierarchical file system. This thing right here, the comb, right? There's root, there's slash. Here's our upper level folders. And then under home, it branches out and so on and so forth. Now the Linux file system can get very, very deep. This hierarchy can go 20, 30 layers deep in some areas. Our concern here, though, is the upper level directories. bin, sbin, etc, user, which stands for Unix System Resources, and our home folders. These high-level folders have specific functions. And even though there's going to be some difference between distros as to what some of these folders are, most of these are common to all Unix distributions, proprietary Unix and Linux Lite. Things like bin, etc, right? Bin will always hold your binary commands, your binary programs for normal users. Sbin will always hold the system binary commands or the programs. These are the things that make up the operating system. etc is always configuration files, plain text files. Home folders always hold the home folders, and so forth. You're going to really want to know what these folders are. All right, this is a slide you're going to want to spend a little bit of time studying, not just for the test in this class, because I am going to test you on these, but actually in the field working. You need to know where to be able to find things in a Linux system. So let's introduce a few brand new commands that we haven't seen yet. So I go to my SSH session here into my virtual machine, and you can see where I'm sitting. I'm sitting in my home directory, right? I'm Bob, and I'm sitting in Bob's home. And if I do an ls, there's all the folders and files that we have inside my home directory. Well, what if I want to make a new directory? We have to do that sometimes. Actually, you have to do it quite a bit. You have a command, mkdir, stands for make directory. No big leap there. mkdir, and for an argument, it takes the name of the directory, what you want to name it. So I'm going to call this one folder 1. And there it is. Notice it's in blue, right? So that tells me that's a directory, it's a folder. And there I am. And I can cd into it. Oops. And I'm sitting inside of folder 1, as you can see on my path right here. Now, there was a command that I want to introduce that we didn't talk about before. Last week, we introduced editors like Vim to go in and create text files, empty files. There's another way of doing it too, and it's a method of creating an empty file. And that's done using the touch command. So touch and then the file name. Call it file 3. And here I have, under my new directory I just created, I have a file called file 3. Now there's nothing in file 3. It's an empty file. It's like a blank post-it note, right? There's nothing in it, but it does exist as a file. Maybe I want to move something around, right? We have to move files all the time. Well, let's see what that looks like. I just created file 3 in folder 1, but I don't want it to be in folder 1. I want it to be in the folder up above me. Well, I can issue the move command. The command is mv, right? And you know what? Remember we have this awesome thing called the man page? Let's use it. If I do an MV move, or excuse me, a man on the move page, the move command, here's what it gives me. Wow, okay, that looks like quite a bit. But notice right here, my synopsis is MV, source, and destination. Let's see what that means. Okay, so I want to move file 3 up one level. Move, and then for my argument, I'm going to take the source file, which is file 1, or excuse me, file 3, and then where I'm going to move it to. What did I just type in there? What does that mean? Well, file 3, and I don't need to give a full path to it because I'm sitting in the directory. I can see it. And remember these characters right here, my meta characters? That's shorthand for one directory layer above me. Now if I do a listing in here, folder 1 is empty. But if I CD, and I'm using my shorthand again, my meta character to go up one level, there's file 3 sitting right there. And I could totally do the same thing. I can move right down into that directory also. So say I want to move file 1, and now I'd have to specify the folder. Well, I can use a relative path name, right? I could do this. Bob, folder 1. All right, see that? Or I could do this. Just folder 1, a relative path name with no leading slash, because from where I'm sitting in my home directory, I can see folder 1. As you can see, they both work. Files 1 and 2 are gone. Isn't that interesting? Get used to using your relative path names. Get used to using your shorthand. You really don't want to have to type out absolute path names every single time you type something. All right, maybe I don't want to move a file. I just want to copy it. I want a copy of it. Well, I can do that also. If I'm sitting here, I'm doing file 3, and let's make a copy of file 3. Copy. Oops. The syntax for the copy command. My source file, the file I'm copying, and then the name of what I want that file to be once it finishes copying. Actually, let me clear that. And notice now I have file 3 and file 4. And those files are identical. In fact, I don't think there's anything inside either one of them. Nope. So they're two empty files. I can also copy to another directory. Right? I could do this. Maybe I want to send that back into my folder 1 folder. I want to make a copy of it. Let's do a relative path name. Folder 1. Call it file 5. Let's see. What syntax here? That's some weird stuff right there, isn't it? Oh, you know what? I forgot. I misspelled it. It's all in the details. There we go. Now if I do an ls of folder 1, I can see my 3 files that are sitting inside there. Alrighty. Now the thing about the move and the copy command is that they can also do something called a recursive copy. So let's say I had a whole folder full of files, like right here, right? And I want to copy everything from folder 1 to a different folder. Well, I could sit there and do it one at a time. Copy file 1 to the destination, copy file 2 to the destination, copy file 3 to the destination. Wow, that would take forever, especially if my folder didn't have 3 files in it, but 300 files in it, or 3,000. Well, there is a way around that. If I issue a copy-R, now notice I'm using the copy command now with the switch, right? Oops. Remember, it's in the details. If I issue a command such as this, it'll go through and not only copy folder 1, but copy everything inside of it and put it over in folder 2. Move does the same thing, and it's very useful if you're trying to move large numbers of things. You need to be careful, though, because you can move something you didn't plan on moving if you do too much recursiveness. Now, there is some protection built into the system. Both the move and the copy commands will warn you, right? If you're about to overwrite something or blow something away you're not supposed to, it'll say, hey, do you sure you really want to do this? That's actually due to an alias, and you could shut that off if you wanted to. Don't shut it off yet. But later on, as you become more experienced with these Unix commands, you may not want to be reminded 50 times every time you deliberately want to copy something over. So you may want to force that. Let's say I do want to force something. Well, if I issue the -F command, that's a force. So by default, copy and RM actually run interactively with the -I. That's what it's called when it warns you. It's interactive mode. If you shut it off system-wide, you could re-enable it, or you could use it each time by saying, hey, do this interactively. Or if it's on by default like it is and you don't want to do it, you can do a -F. Warning, things like an RM-RF/ could be horribly dangerous, right? That means you're going all the way to the root of your file system and say, delete everything recursively all the way down and don't warn me about it. Now, modern Linuxes won't let you do that. It's smart enough to warn you, going, hey, you're nuking your system, stop it. Older Unixes, though, didn't, and it was totally possible to blow away your entire file system with that simple command. Even though there's protections, though, you kind of need to be careful, right? What if I want to get rid of a file? We already talked about I alluded to the RM command. Well, here it is. It removes files. So I'm sitting here. Let's see what we got. I hate file 4. I want that to go away. That easy. All right. Remember, RM also runs recursively. So if I told it to RM folder 1, it would go into folder 1, delete every file inside of it, and then delete the folder itself. And if folder 1's hierarchy was 15 layers deep, it would go through and delete all 15 layers. Recursive removes can be dangerous. You need to use them carefully. And using it with the recursive force switches could have some pretty catastrophic events or effects. So be careful about using this. What if I want to get rid of an entire directory? I might want to. We hate the folder 1 folder. We want to get rid of it, right? Well, I've got a command for that. rmdir. If mkdir made a directory, rmdir deletes the directory. Okay, no rocket science there. So I should just be able to do this, right? Okay, that's a loaded question. It's not going to work, but let's find out why. rmdir failed to remove folder 1. Why? Because the directory is not empty. rmdir as a command is actually kind of limited. It only deletes directories when there's nothing inside of them. Well, okay. I could cd into folder 1 and just rm all the folders out of that, cd back up and rmdir the folder, or I could do this. That recursive remove on folder 1, right? That actually works. and it cuts through it whether there's anything in there or not. Very useful commands, but apply with caution. All right, so I want to go and find stuff. We've already talked about how we need to know what our file system looks like, the hierarchy, so I can find things. But you're not going to know where everything is. Well, we have a couple tools for that, and one we've already looked at previously. A new one is something called the locate command. And it's simply a command, locate, and you can search on file names, and it'll go out and find it. Well, the thing is, the locate command works very, very quickly because it actually is referencing a pre-made index database. When you build the file system, the file system went out and created locate's database. So instead of having to actually search the disk, which if you have like a 500 gig or terabyte disk could take a long time, locate simply searches for the database. All right, how about what happens then when you add or remove files and do stuff? Won't the database get obsolete? I mean, how does it update? Well, it will become obsolete unless you update it. So you can use the update db command that periodically that will cause your system to go through, scan all the files in its file system, and update this little locate database. Maybe, though, I need something more powerful. Maybe a file name is simply not enough. Well, that's where the find command is. And we talked about this previously, right? Most commonly, it's used with the name switch, which is a file name. And we saw the criteria, so it's find, and then where you're going to start searching from. What am I going to be looking for? In this case, the file name, and it's going to look for anything with the name project in it, right? And as we saw, we can use wildcard characters and all that type of stuff. There's lots of things I can use the find command to search on, right? I can search for files based on how long ago they were accessed, if they're empty, what groups they're owned by, when they were modified by it, their sizes, the type of file that it is, all kinds of stuff. Most commonly, we're looking for file names. But many times, especially if you're shell scripting, if you're writing an executable script, you may need to parse part of your file system, and the find command gives you some pretty powerful tools for that. A couple other commands we should be looking for. One is called a path variable. Now, path variable, what does variable mean, right? It's like algebra. It's just a character that can represent something else. We have what are called system variables, and there's a whole bunch of them that the system uses just to record certain pieces of information. And one of them you have is called your path. The path is by user, right? So, and what it does is it contains all the folders in it. It's a list of folders where the system needs to look for executable files. Right, so if I have a program, and say I have the Linux version of Call of Duty 47, and I want to run cod47.exe. If I don't know where that folder is, right, or if I'm not in that folder, well, I would have to give the entire path name. I'd have to sit down here and go like, maybe it's under opt, games, COD, and I'm just making this stuff up now, but you get the idea. Well, what a pain in the butt. I don't want to type that entire string out every time I want to play my favorite game. If I put this directory, opt, game, COD, and again, I made this up, don't go looking for it, in my path, my system path, then all I have to do is type the name of the file, cod47.exe, and the Linux system will go through and search every one of these folders until it finds that executable file. And look at the ones that's already in here, right? User local bin, binary files, user bin, a lot of stuff under user. This stuff under my local home folders. And I can totally change this. We'll talk more about how to assign values to system variables later on. Very briefly though, if you want to look at your path or look at one of your system variables, you would use the echo command. And then you just give it the name of a variable. Now, what's with the $? Under Linux, I have to specify variables first with a $. So when I type that, that means what's following is going to be a variable. They can be variables that I define if I'm shell scripting, variables that are system variables, whatever. But that's how I display them. Don't stress too much over that. We're going to be talking a lot more about that when we get into shell scripting. Another really useful little command is the which command, right? And it kind of helps me find my executables. It searches my path. So we have this command right here, ls. We're totally used to using it. Where does it actually live? I wonder. If I type which ls, it tells me all kinds of stuff about it. So the command is which, and the argument is the other command it's looking for, the program it's looking for. Because remember, Linux commands are really just a bunch of little programs, right? Well, we see that ls is actually aliased. More about that later on. That's what actually gives it the coloring. And then the executable itself lives under user system resources in the bin folder. And right in there is the ls command. It comes in really handy if you're looking for specific files. And that brings us to the topic of linked files. But before we understand linked files, we have to understand how the operating system stores data on the disk. And for that, we're going to move on to lecture number 2.